by contrast, if we want to decompress, the process will look a little different. So as we just saw, this is the compression workflow. This is the decompression workflow. We're given a bit stream, which consists of the decoding try, which we need to decode the code words, and then all the code words. So in this case, the workflow will start by reading in the decoding try. And as before, I'm not going to tell you how that works. If you want to know the details, check out the optional textbook. So trust me, there exists a way to read the sequence of bits, and voila, there it is. We've got it back. Okay. It's kind of similar to what you see if you're trying to write out data structures for, say, project 3 in this class. So that might give you some hint of how that might work. The next step is we are going to do a bunch of prefix matches on this code words data. So 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, etc. We're going to look at this try and find the longest prefix match of 0, 0, 1, 1, 1, 1. Well, that turns out to be just 0. Okay, so the longest prefix of this in our decoding try is 0. So we're going to write out this symbol. And when I say write out the symbol, if we're using 32-bit Unicode, I'm going to put out 32 bits. And as you imagine, that is the correct 32 bits. That's what we originally started with. Okay, so now we've processed this. So we do another longest prefix match, and we get another one of these characters. So we're done with the 0. If we do another prefix match here, now I'd like you to use this decoding try to figure out what will be the next symbol. All right, so now we got 1, 1, 1. So it's going to be this character. And we repeat that process over and over and over and over until we have processed all the code words. And so now we see that the output bits here, well, it turns out this character in Unicode is 1, 1, 1, 0, 0, 1, 0, 1, 1, etc. And we've recovered the original uncompressed bit sequence. All right. So to summarize, the way Huffman coding works is given a file that we'd like to compress into a .huff file. I mean, I just made that up. We're going to consider each symbol, and that symbol could be 8-bit ASCII characters, it could be 32-bit Unicode characters, or it could just be arbitrary chunks of data, like say image data or sound data, whatever it is. I'm then going to count occurrences of each of the possible symbols. So if I have 8-bit chunks, there are 256 different possible characters I could see, like A, B, C, D, E, F, G, exclamation point, and so forth. And that is what I'm going to use to build my code. And that's going to be represented as an encoding map and a decoding try. So we use the Huffman code construction algorithm to get the decoding try and the encoding map, and we'll store the try at the beginning of x.huff, and then we write out the code word for each symbol. Okay? And decompression is just the opposite. Now, if you want to know the exact little details, the implementation is not actually so bad. So it's in the optional textbook, which they also provide on their website, and you can even see the code that they use to actually write the try. And you'll notice it's very short, right? It's just a tree traversal, and it's pretty cool that it is so simple. But again, didn't have time in lecture, so that's that. All right, oops, hi, it's me. So that wraps up, that wraps up our discussion of Huffman coding. And so to close out this lecture, we're going to, in the next video, talk a little bit about compression theory, setting the stage for our next and final lecture.